Namaskar, welcome back. This was our last slide where we stop our discussion about the plate deformation pattern, where the Indian plate is colliding with the Eurasian plate, and some places what we see is the subduction going on. So, on the eastern side, as we discussed in the previous lecture also, that there is an oblique subduction which is ongoing, and the result of that subduction and the plate motion is the well defined Sagine fault, on which we had a recent earthquake of 2025. On the eastern side is showing a movement which has been shown in this figure also, that it moves, this portion moves like this, and this portion goes because this is a part of the Indian plate. Okay. So, this portion is moving in this direction, and that is the reason why we see that right side is coming down towards us and the left side is moving up. So, and here also the motion that is on the western side, the motion, sense of motion what we see, or the movement we would say, is left lateral. Okay. So, left side is moving towards us and the right side is moving away from us actually. So, this is the Chaman fault system, which lies in Pakistan, but is a part of the Himalayan orogeny. Now, several such strike slip faults, we will come to that. What do you mean by strike slip fault, normal fault, and the reverse fault? Similar in a way where we have discussed about the divergent, convergent, and transform plate boundaries. So, this area also marks a sort of a transform plate boundary, which initiated way back when the Indian plate collided with the Eurasian plate, or initially there was a subduction, but the main deformation pattern evolved after the collision. And there is the second cartoon, if you see, it explains that there is an extrusion of this portion. Okay, and this is what we also see in the GPS measurements which have been done by many other groups, which shows that the portion of the Tibetan side, that is this one, this whole portion is squeezing towards southeast, and that's how the different fault have developed, not only in the Indian side, but also in the Chinese side, and then Indonesian side, and if you say the portion of the Pakistan side. Now, transform fault boundaries, as I told that those boundaries we have already seen and discussed briefly before also. Along a transform fault margin, two plates grind past each other in a horizontal fashion. So, that means if you are having the two plates, for example, you mark this plate 1 and plate 2 here, okay, then the sense of movement will depend how they are configured with respect to one another, and they will show the movement. Okay. So, for example, if you say that this right hand side uh, and this is left hand side, so right hand side is moving out, then it will show something like this. Okay. So, this will be in typical movement, sense of movement you will be able to see, where one plate is moving towards you and one plate is moving away from you. Okay. And the same way you see, if there is an left lateral movement, the left block or the left plate will move uh, towards you and the right plate will move away from you. So, mostly we see an horizontal movement along with this, but in nature this is not always possible. Okay, because we usually come across that you have a combination of uh, more pattern of deformation that we will learn when we are talking about the different type of faults and all that. Okay, because there will be a sort of an reverse movement where the one block is also along with the horizontal movement it will go up and it may go down also. Okay, that what we call the reverse component. If your block is moving, like for example, if your movement is like this, okay, this is a purely lateral movement, but if your movement is somewhat like this where the block is moving up, then we say it is a combination of both, that is reverse and strike slip component. And usually this has been seen where there is an oblique convergence, that is oblique subduction is going on. So plate is not exactly at that very right angle it is subducting down, it might be having some sort of an oblique component. Okay, further this margins involves strike slip faulting in the shallow lithosphere and often a bordered shear zone deeper in the lithosphere. So close to the like we can say the crustal crust close to the surface, okay, you may have multiple faults which are coming up, and deeper they are going to be rooted in the same major fault system. Okay, for example, if I put here, so then you have multiple faults which are coming up here, and at the deeper you may have the convergence of the in the lithosphere side. Okay. So most transform faults occurs underwater between oceanic plates. Like it says that the study says that most of the transform faults are there because you have spreading centers and all that. Along with that also you have the transform faults, but there are few major transform faults which are on surface also. Like as I told that you have this Sagain fault system, it is a transform fault system, and on land we have also Karakoram fault and Chaman fault also, which is seen, and then San Andreas fault system is also on the surface, but they have its connection further in the oceanic plate also. Okay. Second, two most notorious, notorious in the sense dangerous in the sense you are having they are capable of triggering a large magnitude earthquake and damaging earthquake. So on land, if you see this, as I told, one is your San Andreas fault system, and another one is Northern Anatolian fault in Turkey. So this is in US and the San Andreas fault system, and Turkey also recently proved that they are the most dangerous faults on this planet. Okay, that is a North Anatolian fault. We had a recent earthquake a couple of years back on this also. So this is your San Andreas fault system and the Northern Anatolian fault system. Okay. So Northern Anatolian fault system is again a right lateral fault, and this one is also a right lateral fault. So this is from between the Pacific plate and the North American plate you are having, and this one is having between the Northern Anatolian fault and the Eurasian plate. But there is also some sort of an influence, I would say, of the Arabian plate and the African plate to this part of the continental plate, that is northern or the Anatolian plate. Okay. Now, we have been discussing since long that this plate motions and the plate tectonics have given rise to the two locations, that is in terms of the height and depth on this planet. So, one is your Mariana Trench and another is the highest point on this planet. So, Mariana Trench is around 11,035 meters deep, and you have the Everest, that is in Himalayas, we have almost like 8,850 meter high. Okay. And both of them are the result of your plate tectonics. Okay. So, development of the topography has been influenced by the plate motion and how the plates have been moving with respect to one another and how they are having based on their configuration in terms of the plate boundaries. Okay. So, you have the major areas of high seismicity if we take, of course, this region will not have much of like great or large magnitude earthquakes, though they are continuously spreading and pouring the magma and building these are the constructive plate boundaries, where new plates are been added up, or the new material is been added up to form the plate or the crust. And this area, that is the Mediterranean belt, which also includes your Himalayas, okay, are very dangerous in the sense in triggering the earthquake. They all trigger mostly shallow earthquakes. Okay, and then another area is your what we call the Pacific Ring of Fire, and we have discussed about that. This region is having like the alignment or the locations of the volcanoes, and some of the volcanoes are really deadly volcanoes, we can say, and they have resulted into a devastating situation in the past. Okay. Now, configuration of the tectonic plates, just briefly we can look at, and then we move to the new topic. So, we have this mosaic of the Earth's crustal plates, what we are having, and the red arrow shows the divergent plate boundaries in the figure here. In many places you will see that. So, these are all the spreading centers where the plate moves apart and create new lithosphere. So, this is what we were talking about, the constructive plate boundaries. Then with the blue arrows, which are shown pointing opposite to one another, they are all convergent plate boundaries. So, these are your divergent plate boundaries creating new lithosphere, and then they are having convergent plate boundaries where plate moves together. Oceanic lithosphere is recycled because it goes down back into the mantle. Continental plates are deformed. Okay. So, the deformation is taking place, and this also we discussed that these are known as your destructive plate boundaries. So, you see those over here in this area, and also the example which we have discussed about the Nazca plate and the South American plate. And even in some locations, because this area, that is your Northern American plate and your Pacific plate, where the Pacific plate is subducting obliquely, because it is not exactly perpendicular to another except one location over here, but mostly it shows the transform fault system. So, transform fault system plate boundaries slide horizontally past each other, where if you see in this region here, they may not be producing large magnitude, or like it will not show the major seismicity, but this regions where you are having this subduction going on, and the collision zone also the Indian side, if you see this one here. So, these are showing the transform plate boundaries, as we have discussed in previous slide. Okay. So, this side is your Sagain fault system, and this is your Chaman fault system you are having. And further, this portion of the Himalaya, the whole Himalaya, if you take this line here, then this shows a sort of your convergent plate boundaries, because initially the boundary was like we had an oceanic plate which subducted below. So, this portion shows the convergent, and I would say the collision plate boundary. So, in this areas, these regions are also capable of triggering large magnitude earthquake or mega earthquakes as compared to what we see in other areas. Okay. And Himalaya also is the area where we have experienced earthquake of magnitude up to 8.5 or so. So, further if we look at the three type of plate boundaries, okay, you have divergent, convergent, and you have transform plate boundaries, and some locations of those let us see quickly. So, you have divergent plate boundary where you have the oceanic plate separation is going on, and these areas are basically seen under the sea, and they are termed as mid Atlantic ridges. Okay. So, this is nothing but your spreading centers mainly. So, this is an example which has been shown between Northern American plate and Eurasian plate. So, where we see a sort of an rifting volcanoes also you will come across, but not a major one as we see in the subduction zone, and of course, the earthquakes. Okay. Then we have the divergent plate boundaries, that is your continental plate separation. And this example we have seen one from the East African Rift Valley, and another one we were looking at is the Iceland. Okay. So, you have again the Rift Valley here, where the two plates are moving away from one another, that is African plate and the Somalia plate, and resulting into the extensional faults which are developed here, and a valley, because if the extension goes on, then you have a formation of depression, and that is what we call valleys here. So, this will also have volcanoes. Volcanic eruptions will be there, but not as massive as we see in the subduction zone, as well as earthquakes also, because of the fracturing and the movement along those fractures, which we call the extensional faults. Then we have ocean convergence. Okay. So, oceanic plate convergence, and these are, we term this as an convergent plate boundaries. We also term this as an destructive plate boundaries, where one of the plate which is subducting below the overriding plate, and this we have discussed that this will be an older plate, because in terms of they are more denser. Okay. So, this is an example again of between the Philippine plate and Pacific plate, and wherever there is an subduction and you have an ingredient which is there going below into the mantle, that will result into melting of your rocks and result into the volcanic eruptions. Okay. So, there you will see a sort of a volcanic arc in that region. So, this and another feature which we discussed was that the deepest portion or the deeper portions will be developed here, where you are having the configuration of, or where the two plates are meeting, that is, one is subducting below and another is overriding. Okay. And these are the most important and the landform which we just saw, that is 11,035 meters, is your Mariana Trench. Okay. So, here what you see is that you will get the deeper earthquakes. Other than that, you will also see, you will come across the shallower and intermediate earthquake, because you are having the plate which is subducting below. So, along this boundary you will be able to see the all in deeper, intermediate and shallow earthquakes. Okay. And also within the plate also you will see that. Now, coming to the another type of just the configuration is changing, because earlier we were having oceanic, and now what we have the oceanic and continental. Okay. And as we have already discussed about this, that we will the continental plates, because it is lighter in terms of the density as compared to the oceanic plate, this will not subduct. Okay. So, only the heavier plates will subduct. So, Nazca plate is an your again a oceanic plate, and similar features will be seen as we have, or the landforms will be seen as we come across the oceanic convergence, and we will see the volcanoes on the overriding plate, and we will have a formation of trench. That is again another one, the most important feature. So, this part remains more or less common here, but the volcanoes here which you see the Andes mountain, the volcanoes will be on land. Okay, that is on the continental plate. So, this is your continental plate. Okay. So, this is the only difference there. What we were looking at is the on the oceanic plate. Okay. Again, we will discuss about this. There will be a trench here, but this trench will not is not similar to what we have seen in the Marianas type trenches. This part we will discuss very soon in coming slides. Okay. That what is the difference between why the scientific community has categorized the two type of trenches. Okay. There is one is the Mariana Trench and another is that is Mariana type of subduction zone, and you are having the Chilean type of subduction zone. So, here again what we will see is that you will have the folded mountains, you will have deep earthquakes, you have intermediate earthquakes and shallow earthquakes. Okay. And plus you will see the volcanoes which have been developed here. So, in this region also again there are active volcanoes sitting on the South American plate. Then comes the convergent boundary again, and this is an example of where initially convergence started, but later on due to the continental plate we started having a sort of a collision and building up of your Himalayan uh, Himalayan mountains, okay, Himalayas, okay, we can say. So, here what we see, because the similar crust we are having both are continental. So, we will see a sort of a crustal thickening. Okay. This is an important point in terms of what we see in the Himalayan side plate boundary. Okay. Folded mountains and earthquakes again we will mostly see, because there is no subduction or no pouring of your oceanic plate has been seen here. So, we will not see the volcano at present, the ongoing condition will not see the volcanoes. Earlier we had volcanic eruptions on the Tibetan plate side, but now there is no volcanic eruption, because there is no feeding up of the oceanic plate here, and we will have mostly shallow earthquakes in this area. We do not see deeper earthquakes as we see in the subduction zone area. So, this has also been categorized under convergent plate boundaries, but now what we see is this little convergence, but mostly it is the collision which is going on between that. Transform plate boundaries will be seen between the spreading centers. They will be mostly you will not come across many earthquakes here, but few earthquakes of like low magnitude earthquakes we can say, but not very large magnitude earthquakes in this area. So, this is basically the spreading centers we are having in mid oceanic ridge or mid Atlantic ridge are the best example for this. Okay. But along with that, as I mentioned, that there are few on this planet which are notorious, like so you have the Pacific plate obliquely subducting below the North American plate, and that has given rise to an the plate boundary, what we call the fault system, which we call San Andreas fault system. So, here also you will have, but here you will have major earthquakes, okay, large magnitude earthquakes in this region. Now, further, this is the final what we have, the digital tectonic activity map, which shows the location of the volcanoes, location of your active earthquakes and all that. So, coming to the part which I was trying to explain, that we have based on the alignment of the earthquake occurrence in this area, one can classify the boundaries. Okay, that is what we call the active boundaries and the passive boundaries. Okay, so passive continental boundaries includes those facing the Atlantic, Indian and Arctic oceans. Okay, and these are, if you carefully look at, then you have mostly you see the spreading centers over here, and they are basically, and this one, so they are categorized by very few earthquakes and considerably inherently stable. Okay, but yes, of course there is a moment there along the passive boundaries, but there is the earthquakes which will be triggered are not very large magnitude. Now, active continental boundaries which have been marked includes those facing Pacific Ocean and other extending from the western side of the Pacific Ocean through Indonesia, China, Central Asia and Middle East. Now, these are the boundaries which are very active and dangerous in the sense, because they are capable of producing large earthquakes and mega subduction or mega thrust earthquakes or mega subduction zone earthquakes. Okay. So we'll stop here. We'll discuss more about the plate margins in terms of the trench, okay, and that is between the in subduction zone area. So I'll stop here. We'll continue in the next lecture. Thank you so much. Namaskar.